everyone. I'm Delly Credo. I'm the co-founder and CPO of Codium AI. Codium AI will provide an AI coding assistant that is quality focused and that works for complex enterprise code bases. And today we're going to cover a wide variety of topics about how we can approach code gen, how can we improve it, different techniques for context awareness, testing, code review, kind of a pretty wide variety of topics. Feel free to ask questions in the chat. I'm just going to verify that you can hear me okay. Okay, great. So feel free to ask questions in the chat at any point. We'll try to tackle some in the chat, and I'm going to stop, also pause once in a while to answer questions. Great, so let's dive in. Okay, so everybody's speaking about AI code gen and AI coding assistants, and as we know, so many developers are using a variety of coding assistants, right? So we see that nowadays we're talking about larger numbers, even than 90%. But what people are not, I feel at least, not talking about enough is the issues that this introduces. A lot of the generated code, there are studies that show that a lot of the generated code is being abandoned or getting churned after some time. So even more than more than 30 or more than 39%. And also some mistakes that happen because it's very easy to accept code that is being suggested. Does not necessarily mean that the code is of high quality, that it aligns with the best practices, that it doesn't contain bugs in it, and or maybe it has some kind of hidden bugs or hidden issues. And this can lead to significant problems for enterprises. We believe that code generation should be fueled by code integrity. But before I deep dive into that, let's run a quick survey. What does code integrity mean to you? When you hear the word or like the phrase code integrity, what does that mean to you? And let's see, Ilana, I'm assuming you can start the survey, not like to figure out how do I do that. Okay, polls.
I'm going to try.
Yeah.
I think you can keep going, and when we'll get it working, we can take a pause. And
okay, I see it. It's like I see
that.
poll 1 and poll 2. Which one should I do?
Number 1.
Number 1. Okay, I'm launching it.
Great.
Okay, perfect. Let's see let's give like a minute for people to answer. Okay, so far I see 0 out of 71 participants. So come on, guys. All right, I see some questions flowing in. Okay. We got more than 10 responses so far. Going up. Okay, we have 22 answers, 23. I'll give it like, I'll count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we're at 29 responses. I'm going to end the poll. And let's see the details. Okay, so I'm going to close this. Okay, so we're seeing code consistency over the whole project. I think this is great. Definitely important to align with a broader context of the project. Something that is reviewed and inspected and tested. Let's see some more interesting quality, no bugs. What about anything about intent? Robust code that will perform as defined, That's a critical one. That's a crucial one. How do we really align the spec, the actual requirements of what we're trying to build with the actual code? Correct and consistent, runs as intended. So this is really great stuff. I see that you guys know your stuff. Reliability, security, authenticity, bug-free. Yeah, it's pretty consistent. Right, I'll go back to the slides. So really what we're talking about when we say code integrity or high quality code generally, we're talking about code that is both syntactically correct, but it's also semantically correct. It's also aligned with the spec, aligned with the requirements that we're trying to build. And it's tested against different edge cases and happy paths that are well defined. It's thoroughly reviewed and checked. And it adheres to the best practices and the standards of your specific organization and your specific team. Okay, this is how we see code integrity. And we believe that nailing this is crucial to really adopting code generation or AI coding in general at scale. So why don't we have today fully autonomous AI developers everywhere that are just doing all the work for us? We believe that there are a number of issues that are causing this, I would say. Or so like one main area is everything around context. So AI needs to really, the LLMs, the AI need to really understand the context of the broader code base and even beyond the specific repo, across repos or across areas of your code base in the organization. And that's a very, very challenging problem. And even as the context windows are increasing for the LLMs, it does not mean that you can actually have that context window and that the LLM will actually really grasp and understand everything in it. That's a really core like challenge. Validation of the code quality. So we need to have the right methods, the right user experience to validate that code is correct. And eventually, I think nowadays developers are still kind of left hanging on their own to do this heavy lifting of reviewing the code, testing the code, still leveraging the same methods that we've used for many, many years, generating tests, unit tests, integration tests, end-to-end tests, and then eventually kind of reviewing the code manually in the Git environment, GitHub, GitLab, Bitbucket, whatever you use. These are systems that have been around for a long time, but that not necessarily are adapted for the new world of AI code or code that's generated by AI. Full awareness of the developer's intent. So I think I think this is actually a major challenge that people are not talking about enough. I see this a lot. It's a challenge to when you work with a certain chat interface to generate code or any type of kind of interface for code gen. One of the major challenges is to be able to express your intent in a very clear and concise way so that to give the highest chances for the LLM to actually generate the right code. So if we take a step back for a second and we think about, or we kind of look at how LLMs quote to quote think today, say quote to quote because it's kind of debatable whether they're actually thinking. But this is like more, you can think about it more as a fast, reflexive decision making, kind of a system one type approach where we're predicting token by token. It's attention based, sequence to sequence. Eventually, transformers predict the next token, and they really like express the patterns that they have in their training data to make these predictions, and they're more heuristics based versus like kind of deep reasoning. People use a lot the word reasoning, but really what's in the core architecture of LLMs today, it's more heuristics based. They're predicting the next token. So they're training mostly on open source data, and they get inputs in the prompt, including the code and some instructions, typically in some system message. And then they tokenize that. They kind of match the patterns through the network, and then they generate the output token by token. And the limitations for that are significant. So as of today, like I feel that LLMs are very, very helpful. Mostly when we talk about enterprise use cases, it's mostly for generating code snippets, smaller tasks, repetitive tasks. But when it comes to very complex tasks that require enterprise level code-based understanding, it becomes quite challenging for these LLMs. People like to always share on Twitter the really cool stuff and how I wrote a prompt and I got a full working app. But when you really like look at enterprise code and you try to do some stuff that's really complex, you'll sometimes find mistakes that to even a common developer like would seem obvious. So that's the challenge there. So obviously overfitting to the patterns that are in the training data is a problem. Maintaining consistency across the code base. And then how can we do the error handling, the debugging, and really like in many cases, the LLM suggests when you try to get a fix, they suggest a fix that it suggests a fix based on like the patterns that it was trained on versus like kind of really, really understanding the core like issue at hand. So as we are trying to really take these LLMs into production and work well for enterprise code, there is quite a lot of best practices that we are learning along the way. Here you can see a few of them, mostly coming from our Alpha Codium work. So we've released Alpha Codium as a competitor in coding competitions, and it achieved state of the art in coding competitions. And then the things that we learned from it are things like the importance of structured output, specifically YAML, we believe is a very good format for that. It's quite good from a token budget perspective, and it's really important to give the LLM a structured format. We find that using semantic bullet points is also helpful, as the LLM is, especially when you do multi-steps or flow, what we like to call flow engineering. As the LLM is doing the quote-unquote reasoning steps, listing out everything in bullet points is really important. It's good to always encourage the LLM to generate modular code. Obviously, it's a general best practice, but specifically, kind of like sometimes LLMs tend to forget that. Soft decisions with double validation is a really cool one. Like when you have time, like in the case like what we had with Alpha Codium, where we are actually running a process that reasons and do multi-step. If you let the LLM actually generate first an output and then kind of review that output and regenerate it as it's correcting it, we found that technique to work quite well. So instead of telling it, like not asking kind of a one question, is there a problem here? More like kind of rewrite this code and fix any problems that you find. It's always good if you have the option. It's always good to generate. If you're building a system like an agent, if you have the option, the room to generate multiple suggestions or multiple implementations of the same code and then evaluate them further down the line, it's always good. And like as we're seeing, like generally with the chain of thought or flow engineering, and also like in the new models like the O1 model from OpenAI, a flow-oriented process where there's gradual accumulation of data and knowledge really helps to increase the quality and the performance for like reasoning type tasks. So gradually, like splitting the task into multiple steps, and even considering injecting additional data at different steps. So how can we actually achieve code quality, high code quality with AI and generating code that can be trusted? Contextual awareness is key. Like we find that it's really important to both do high quality or robust techniques for indexing code, both at the local level inside the IDE, as well as a more advanced RAG that retrieves context from the enterprise level code across the repos of the enterprise. So we have both of these concepts today in our product, and we're constantly iterating and improving them. Similar to how whoever remembers the GANs, like generative adversarial networks, that was a kind of a really cool concept of architecture in AI, where you had a critique network and you have the generative network, and they were working hand in hand. You can think about tests or code review as if you embed that in the process of the code generation, and you have a critique, and you use the testing and the code review as the critique together with a code generator. We believe that that's a very kind of important concept to build upon as we move forward. And then separating into specific agents that are specialized in different areas, like an agent that is focused on testing and an agent that is focused on code review. We believe that that's a very, at least with the capabilities of AI today, it's a very good approach to kind of specialize these agents and achieve high quality results. Maybe I'll pause here. I covered quite a bit so far. Before we go into more details, maybe it's a good time to pause for a second to see if we can tackle a few questions. So let's see. I'm just going to open the chat. Are there any questions in the chat? Ilana, maybe I'm missing that. Is there? I don't see anything yet.
No, there's no questions yet. Okay. So I think we can keep going.
Perfect.
Yeah.
All right, great. I'll keep going. Perfect. And if anything comes up as I speak, feel free to ask questions along the way. Okay, so RAG, Retrieval-Augmented Generation, like a big buzzword these days, but we believe it is really a crucial capability to nail if you want to achieve high quality code generation for enterprise use cases. So what is RAG? In RAG, we take a set of predefined docs, and in our case, it can be many cases like documentation that is related to the code, to the code base or to the enterprise code, or can be one or many repos. And then we pre-index that information. So we actually split it into chunks. We create embedding for each one of these chunks, which is essentially a numerical representation that kind of represents the semantic meaning of that code or text. And that gets stored in a vector, what is called a vector database. And then at query time, when the user is asking a question in the chat, for example, or about a specific piece of code, or even general question about how do I implement a certain task in the code base, we take this user query with additional supporting information that we may retrieve with other methods like static code analysis that we also combine in our products. That gets converted into an embedding and is then used to search against the vector database in order to retrieve relevant information. And then that information that was retrieved, so this will be chunks of code and potentially text and documentation, and along with the user query would then be fed into the model to generate the final answer. And that's what's called the augmented generation. So augmenting the user query with the additional information. I apologize, I need to pause for one quick second. If there are any questions, put them in the chat. And so that's generally the augmented generation at a very high level. We augment the user query with additional relevant information. And the crucial part here is, how do you, on one hand, create a smart process to chunk the code, because the kind of naive chunking or naive splitting that works for like text when you split by paragraphs can work quite well for just general textual data, but code is a lot more nuanced, and each language has its nuances, and you want to make sure that you include in each one of these chunks additional relevant information. For example, think about the imports in the file, and maybe different types of code would need different chunking strategies that we would need to employ. So for example, if you want to create an embedding of an open API file, you want to make sure that each endpoint is being kind of treated separately. So there's a lot of know-how and a lot of work that needs to be done to do like a proper chunking and kind of storing of this information. So we use some of the open sources, and we use Llama, we leverage also Llama Index as part of this process, but we built a lot of additional layers on top of that to improve the quality and performance. And then in the retrieval,
sorry, I just want to pause. Yeah, I just want to let everybody know they can ask the questions in the Q&A button, not in the chat. So there's a specific place that you can ask questions, and we'll see them and you can answer them there. So not in the actual chat.
Oh, okay,
Sorry
because
to
I was
interrupt,
also
Eddie.
looking. Oh yeah, I was also
No,
looking at
there's a
it.
Q&A button, and so everybody can use that if they have any specific
Okay.
questions. I'm looking at
Perfect.
it. Yeah, cool.
Perfect. Thanks, Ilana. So yeah, so and then the second part of this that you really need to nail is, how do you do the retrieval? And that's I would say is equally challenging. I don't know if to say it's more or less challenging, but you need to figure out a way to convert the user query, and then maybe like add to it additional relevant code that is related to the query that you can use other methods to bring. So for example, in the IDE and also in our Git plugin, we can use static analysis to kind of extend the user query. And then you create an embedding of that, and then you need to search, and then you need to kind of filter the results, because like just pure embedding search will bring you a certain set of hits, and then you need to kind of do another step of filtering and re-ranking to make sure you filter only on really relevant information in order to feed that into the LLM for the final step of the generation. And we actually use an LLM for that filtering and re-ranking step. So that's a key area for us to continue to improve, and I believe that it's going to continue to be critical for code generation generally. So I talked about chunking. I talked about the kind of the embedding side. Another thing that we do is like, it's kind of, I think is quite useful, is to take the code, convert it into text, and then also create an embedding of the text. So if you like describe the code and then you create an embedding of that, it's both in the part of like the indexing as well as like when you search. So that's also helpful. And then I talked about the retrieval and ranking as well. So then some kind of lesson learned, or some areas that we're doing a lot of work on. So both in the kind of like a local repo, it's important to let users like kind of work on their code base inside the editor locally. But then when you expand to the enterprise, across the enterprise, and you want to be able, for example, have a developer ask about like, how can I find similar code to this code, or maybe someone else already wrote something similar to what I'm trying to now build. So especially in large enterprises, it's a big problem. Like so much code is getting duplicated. Or maybe there are certain best practices that I should use when I do authentication, or when I use kind of enterprise level services or capabilities. So for that, we like to kind of use the concept of golden repos. So you create this set of golden repos that should have high quality data, should have like well defined like code that kind of represents a best practice code, and then potentially with additional markdowns that serve as documentation around that code, and then you index those golden repos, and then they get instantly accessible to all of the developers in the organization. And I'll show like some examples of that. And then benchmarking and evaluation, it's another area that is very difficult generally for RAG, because it's very unique to each organization, to your use cases, but it's really important to have a good benchmarking strategy and see that you can track over time that you improve your retrieval, the accuracy of the results of your RAG solution. Okay, just a
I
little
think there's
more.
some questions. There's some questions on the last couple of slides. So
Okay.
I think, yeah, check those out.
I'm gonna try to open this Q&A. For some reason I can't see it.
I'll send them to you now over, because I can direct
Yeah, if you can
message
send
you.
it in Slack, that would be great, because like when I click on it, maybe it's because I'm presenting, it doesn't let me see it. Do you
So I'll read
consider
it.
any files as
Go
a
ahead.
general context source? Any files as a general context source for the code repository or libraries, such as text reading? And yeah, generally yes, especially like text or like markdown is like now I think is quite useful. So yes, and then also like other types of files, obviously like configuration files in TOML or YAML or things like that can also be useful for questions that are related to their configurations. And in my project I have three steps of code generation based on description, gen interface, gen implementation based on the interface and description, and gen test based on interface and description. Test fails, how to detect what is wrong? Test on implementation. That's a great question. So I think one thing that is like, so first of all, it's not always that clear. One way to think about it is to potentially kind of brainstorm both options. So you can kind of have the LLM either present both options. This can be maybe this is the problem with the code, or maybe this is the problem with the test. And then we actually do that in our user experience, and we let the user choose the option. And then you can add another reasoning step. If you want to fully automate that, you can also add another reasoning step on top of that, where the LLM can kind of choose the path. Like, is it like test or implementation? And obviously, the more spec information that you can bring, the more detailed like explanation, the easiest it is for the LLM to decide which route is the right one to choose. For the LLM or for a user for that matter, right? For human. Yeah, embedding model. So generally for a SaaS offering, we use a lot of OpenAI, and we also, so for the embedding, we use on our SaaS, we use the OpenAI model, and for our self-hosted, we use an open source embedding model that we are starting the process of fine-tuning as well. So in terms of storing data in our system, we try to really be conscious of security and privacy. So we do not store your code. The only thing we store is logs for 48 hours just for troubleshooting, and then they get discarded completely. And even that we can kind of remove to zero if needed. And then for storing the embeddings for your repos, we use like, so even in our SaaS offering, if you want to use our multi-repo context awareness, you will have to set up a Postgres database on your infrastructure, because we do not want to store your code. So it's kind of like a hybrid mode. Like we store the vectors in the Postgres database, like on your cloud provider of choice, and then all the rest is pure SaaS. And then we also support self-hosted deployments as well. Okay, will the ability to add other context locations such as library or API docs from web URL? Yes, we are planning that. It's on our roadmap to be able to add, like, for you to give like a URL, for example, and then we can index that as well. And definitely something we're planning to do hopefully in the next few months. And other LLMs besides for OpenAI, we already have a working version that runs with Claude Sonnet 3.5. as well as other fine tunes that we have of open source models. So this is what we use for like self-hosting. And soon we'll expose in the UI the option to switch LLMs. So you'll be able to choose, for example, between Claude Sonnet 3.5, GPT-4o, and hopefully also o1 soon. Yeah, so we use similar techniques to RAG, like to graph RAG, to kind of some proprietary techniques to kind of improve the accuracy of RAG. But there's definitely an area that we are exploring a lot, and there's a lot more for us to do and improve on. So that's the question about like, do we use graph RAG? Okay, so I think I'm going to pause from questions a little bit and let's continue a few more slides. So if we take a step back and think about, like I mentioned this earlier, GANs, like generative adversarial networks, this architecture used to be the state of the art before transformers. And the cool thing about it that you had this kind of two main components, two networks that were working hand in hand, the generative and the adversarial. The adversarial is kind of the critique, and the generative is generating the actual results, and then they work hand in hand. And then transformers came, attention is all you need, and it kind of changed everything, obviously, and brought us to where we are today with the huge advances in LLMs and generative AI. And it works really well for many use cases, right? For text, for image, for audio. It obviously works on the surface. It's actually working quite well for code, right? We know for code completion, it's really cool. It's really nice. But we believe that to really take it to the next level for code generation, we need to kind of think about reintroducing this GAN concept. It doesn't necessarily mean that we're going to have a new architecture for the LLMs. But from a systematic perspective, we got to think about how we do a lot more on the code integrity side. How do we combine testing and code review and build the right UX and the right processes and the right engineering around it, so that we always have like code gen and code integrity working hand in hand. And this code integrity includes really concepts like testing, reflecting, matching the spec, always kind of checking and verifying the spec versus the actual outcome. And we believe that the more we make these capabilities more robust, and this is a lot of the areas that we focus on at our company, we'll be able to really like adopt code generation across the more complex use cases of the enterprises. This is like an interesting concept from how kind of test generation can fit into that concept. And this is taken from our Alpha Codium paper that, as I mentioned, achieves state-of-the-art in competitive programming. And basically, if you take a programming competition, like a problem, and you just direct prompt a really good model, you get something like this, where it's like the correct is the purple kind of cloud, and the solution like is the like teal cloud, and it would overlap, but then it will be wrong in different areas of especially for the complex problems. And then if you do a process where you take the public test, because each one of these problems in coding competition are coming with a set of public tests, and you take these public tests and you create a process to iterate, run these tests, like and I reflect on the results, and then adjust the code accordingly, you can kind of get to something like this, where you narrow it down and you're good, you're spot on for the public test, but you're still missing a lot of the other cases where you're supposed to be good. But then if you take it to the next level and you actually generate additional tests in a smart way with know-how, and you add edge cases, and you try to really kind of cover that potential set of inputs and outputs for a given problem, and you generate a lot of tests for them that are AI generated, you can get a lot closer and nail it for many of these complex coding problems. So this is kind of what we did at Alpha Codium, and these are concepts that we also incorporated in our products. Generally, the flow of Alpha Codium is taking a problem and a description and reflecting on that. So this is what we call it flow engineering. You build a certain flow, but then inside the flow, you have steps that can be kind of repeated. And so there is reasoning about the public tests. You generate several solutions, you rank them, then you generate additional tests, and then you kind of iterate on both the public tests and the AI generated tests on your different solutions based on the order of your ranking, in order to eventually generate a potential solution that kind of fits and meets all the both the public test and the AI generated tests. And okay, so if I take it kind of to what we are building in terms of our products and how we're thinking about this, so we have one component, centralized component, which we call the controller agent. So that's the component that is in charge of the code base understanding, indexing the company's code base, mapping best practices, and kind of storing it in one centralized location. And then we also have the models controller below it. So we have different models that we support. I mentioned like OpenAI, obviously, that is kind of our main. And then we are also, as I mentioned, we're introducing support for Sonnet and also through Bedrock. So one option is to run the platform on your like cloud provider. So it can be your Azure OpenAI, leverage your own Azure OpenAI or your OpenAI account or your Bedrock account on AWS. And soon we're planning to also support Gemini, but it's like based on kind of more requests. We see less requests for Gemini. And then we have the different agents that are kind of represent the different areas of our product or different products that we provide. The IDE agent is what we call CodeUmate. It plugs into both JetBrains and VS Code, and it helps developers as they code, as they plan for a task, as they iterate, as they refactor code, test code, review code inside of the IDE. And then we have PR agent, which kicks in once the PR is opened. It's a plugin into the Git. So plugs into GitHub, GitLab, Bitbucket, and also soon Azure DevOps. And it helps to review the code, to describe the code. And it's a quite robust and configurable solution to really take code review to the next level. We introduced recently a open source tool called Cover Agent, which is focused on auto generation of tests, specifically for regression testing. So it automatically generates tests, it runs them, and it kind of keeps only the tests that are actually useful in terms of both their passing and their increasing coverage. I'll demo in a minute how it looks. It's open source. It's not it's still like, I wouldn't call it like a core part of the offering yet, but it's quite a cool project. It's gaining traction, and it's we're integrating it into our broader solution. We also have dashboards, insights, and reporting, and then there are other areas that we're planning to innovate on, including end-to-end, so testing from a user perspective, and also helping users like bring in the spec from the source system. This can be a Jira or a Linear or like on Monday or wherever you keep your tasks. But then also how do we take a specific task and how do we kind of break it down and how do we create a detailed spec around it? So that's what we're planning to do also there. And yeah, so that's the overall kind of platform and our vision for it. And next, I was going to go into a brief demo to show kind of an kind of pretty end-to-end use case inside both different products. But maybe I'll see first if I can take a couple more questions, and then we can do that. Let's see, Ilan, are there any other questions that maybe we should tackle? Okay, so I've been using GitHub Copilot. Can you contrast the end results generated by Copilot versus Codium, besides the possibility of maintaining indexes on premise? Yeah, it's a good question. So I think the areas that we are really focused on are like complex code bases. So wherever you need to index like broader set of repos, this is where we excel. When you need to do a lot of testing, we build a specific user experience around testing, specifically for unit testing, but also for like a code Q&A, even for your local repo. These are areas that we really excel in. So if I have to summarize it, it's like, I think about it as quality focused, like best practices focused code generation. For example, like if you have a set of best practices for the organization or for the repo, you can take those best practices and you can apply them for PR agent, and PR agent will use these best practices to review the code and to suggest suggestions that are aligned with your specific best practices. So the kind of the customization side of customizing things to your best practices, and then specific advantages that we have in code review, testing. You can, for example, focus on your diff. I'll show this here in the demo in a minute. These are things that you don't have in other solutions. And great. So with that, I think that's a good segue to the demo. So let me switch here to my VS Code. And cool. So here I am in VS Code. I have CodeUmate, our IDE plugin installed. You can search for it, CodeUmate, in the marketplace by Codium AI. As you can see, we have hundreds of thousands of downloads, yeah, quite tens of thousands of weekly active users. And then once you install it, you'll see a few kind of main core functional areas of functionality. One is the chat that is quite, I would say, quite flexible. Another area is the test generation. You can see these links to generate tests. And then we also have like code completion here that you will need to enable or disable here in VS Code. And you also have a similar setting in JetBrains. Generally, you'll see it's really similar, like almost the same between JetBrains IDEs and VS Code. This is another thing that we treat both as highly, highly important, both JetBrains and VS Code. And our customer base is kind of split. We see enterprises are kind of really, really split between the two. So then here I have like this web scraping. This is a project called AutoScraper. It's a web scraping tool. It's quite complex. Here you have like a file with 700 lines of code. And let's do a couple of use cases around this. So first, maybe I would want to add some new functionality to AutoScraper. So what I will do is I'm going to go here. I can also do it with the keyboard shortcut with like an @ open this. And then I can add a file or a folder, and I can just add the full project as context. I can also search for specific files or folders and kind of help the AI to focus on specific areas that are important for me, but I can even start at a broad level and just index the entire project. And again, I'm going to run this question. I want to add a new functionality to AutoScraper to scrape Google Maps. So as you can see, it's like querying the code base, it's collecting the information, and then it's producing the answer. It typically will break it down step by step, okay, to produce kind of a very structured answer. And so it's really nice. Like I got the step one to kind of understand the structure of the data, extend the AutoScraper class, handle dynamic content, and then some additional recommendations around testing and validations. And then I can see in the references everything that was used to produce the answers. So you can see these are all kind of corresponding to different snippets that were collected automatically from the repo, processed, and then were used. And this is actually a combination of both RAG, but also static analysis. And when I say static analysis, these are kind of like things like, looking at the imports and seeing that it's using the utils. It's like importing a lot of stuff from the utils, and they're being used by this class. So then you can see all the utils like snippets that were being used and collected automatically, even though I didn't write in my query the word utils, right? But that part came through static analysis. So combining kind of state-of-the-art static analysis with RAG, I believe, is like the best approach to produce high-quality results. So this is an example. So obviously I can copy these snippets. I can insert them in the cursor. We're going to soon add here like a kind of a magic apply button that you can just click on this whole thing and it will just apply everything. So that's like one kind of core example. Obviously I can iterate on this, right? I can click continue this chat and say, hey, I want this done a different way. Like I didn't like how you implemented this or that. Like the cool thing, obviously, with AI that you can do these iterations and it will maintain the relevant context. And we're now in the next couple of weeks, we're going to roll out also chat history here. So yeah, and then generally this is very flexible. So I can either focus on my current file. I can even focus on my diff. I'll show that in a minute. I can add extra context. I can also select snippets and then add them to the context. Like there's a keyboard shortcut for that as well. So there's a lot of control that you have on the context, which I believe you don't have in other tools like Copilot, for example, and like per the question earlier. So that's kind of like one use case, and I'm going to open quickly another code base here. So this is actually our backend code, like real production code. Okay, we have this utils context utils file with a lot of util functions that we're using for different tasks. And this environment is connected to our broader like indexed environment that is kind of indexing all of our repos. So you can see under the extra context is the company's code base, which means that it will leverage the pre-indexed, like the broader context of the company when I ask questions. So if I, for example, focus here on the limit lines function, let's just quickly run a /explain command so we can understand what it does. By the way, you can hit / and then you get a list of different commands that you can run. So you can either like do free chat or run a set of predefined commands that we have. And the explain command kind of reviews this code, analyzes it. There's several steps. It collects additional relevant context, and it tries to really understand what this is meant to do. So in this case, it's quite simple. It's like a text processing function that takes in a string, a max lines argument, and a direction. Then it trims the string according to the direction and the max lines. But maybe I want to see if I have other, let's say I was about to maybe write this code and I want to just see if there's something similar in my company, right? So I can just do something as simple as like find similar code in our repos. And it knows that I'm referring to limit lines because this is like my focus area, my focus selection. And then it's doing the context collection, the RAG, and then it will bring in additional relevant information from other repos. And you can see it's like actually giving me the file path. This is from a different repo, right? And then at the end, I can see all the different repos that it found relevant code in. And I can see like all the different examples that it gave me. So clip tokens, for example, is another one that is really, really similar. It's basically kind of doing the same. It's kind of like code that maybe we can unify. We have potential to maybe unify it into a single place. Obviously, I can go a step further and say, hey, refactor limit lines based on best practices that you identified, because maybe it's found in other like areas of our code base, like relevant best practices that can be used, and then I can kind of refactor my code to make it more aligned with our best practices, right? So now it's going to give me kind of a refactored version that includes like things like error handling, improved readability, simplified logic, and you can see it used all the information that it gathered from other repos in order to do that. Great, we have 9 minutes, so I'm going to try to maybe shift gears here. So I'll go in here and I'm going to go back into the previous example that we had, which is like the auto scraper. So the web scraping utility. And let's generate some tests, okay? So to generate tests, I can either use the chat. We have a command called quick test, which will generate a few tests, but I can also use our test generation UI. This is what we call the advanced panel, advanced testing panel. So I basically click to test this class here on this autoscraper class. It analyzes the code. It maps the different happy paths and edge cases into kind of a hierarchical structure that I can actually drill down into. And it also gives me a couple of tests that I can generate, that I can leverage right away. And you can see here that I can see additional behaviors, and I can click generate, and it will add these tests. Or I can go here to this edge case, and I can generate this, or drill down, generate. And this basically adds these tests into my test suite. So I can kind of build a robust test suite this way. And I can also run these tests, and we actually have a process that is an agentic process that reflects, and if a certain test fails, it would allow me to fix it. So here we can see a failed test. We can see kind of why it failed, and then the system will kind of reflect and will try to fix it. This is something we currently support for like Python, JavaScript, and TypeScript. Potentially planning to do that for other areas as well, but this can kind of be a process where may take a few steps to get to a passing test. So this is kind of one option to generate tests. And in this case, it didn't, but that also happens. I can just like remove this test and generate other tests. And then I can get to kind of a passing test suite. So maybe if I take these two tests, and I already did that in advance here, I have a file with a simple test suite with a couple of tests here that I can run. I can see that they're passing. And now I can take another step. So this is one way to generate a test. And you saw this is very kind of user focused, or like the user has a lot of control. You pick and choose which test you actually want to generate, and you can pick from the behaviors and generate tests. But now I'm going to open the terminal, and I'm going to use our CLI tool, Cover Agent, that I mentioned. It's a new open source that we recently released, and it's meant to take an existing test suite like this, and it will automatically try to generate addition. It will map it to the actual code, and then it will, or I will actually give it the code file, and it will then try to generate additional tests in order to increase coverage, and it will only maintain tests that it was able to run and pass. Okay, so let's run a Cover Agent. So we'll set a goal for it to 65% coverage, and we'll give it the max iterations of 8 iterations, and it will point into this test file. So let's see what it does. So it starts the process of generating additional, like reviewing a coverage report, existing coverage report, like running the existing test, reviewing the coverage report, and understanding which lines are not covered. And then you can see that it's automatically adding additional tests to the test file. So these are 3 new tests that were just live, like added live. And each step, it kind of reviews the actual coverage that it got to. So now it's like at 59%. It's trying to get to 65. Not sure if it might take it some time to get to, or maybe not going to be able to quite hit it. But that's kind of the concept behind it, right? The test that actually passes will be kept automatically, and a test that doesn't will be thrown away. And this way I can kind of create regression tests for like a legacy code base in an automated manner. So it's quite a cool concept. Okay, and then here we got to the target, so reached above the target. So after 4 iteration, you can see here we got to 66.54%. So Cover Agent basically took an existing test suite that had 2 tests, and it added like 1, 2, 3, 4, 5, 6, 7, 8, 9 additional tests. And all these tests will be like a test that can run and pass, because it actually ran them and passed, and verified that they're all passing and increasing the coverage. Okay, so that's Cover Agent. And then I'm going to end in the last like couple of minutes. I'll shift gears to the last step. So let's say I made some changes in the code, and I can even like go here and I can switch to the git diff and maybe focus on my committed changes and run like a command, like a /issues command. And this is, by the way, another differentiator from GitHub Copilot. Like you can focus on your committed, like on your diff state changes, and you can see that it actually did a code review. It found a security concern, a hard-coded API key. I can see where that is, and then I can continue this chat and ask for a fix, and CodeUmate will suggest like a detailed fix for this that I can then go and apply. But now when let's say I finish committing everything and I'm now opening the PR, this is where PR Agent kicks in. So I'm going to create a new pull request. Let's say I did a bunch of changes, and PR Agent is now connected to GitHub in this case, to my Git environment. And when a new PR opens, it kind of listens in it. It has a set of tools that you can either trigger it automatically or manually to help with the code review process. So first is like the description. So it creates this detailed description of the PR and a file-by-file walkthrough. So now as a reviewer, it's much easier for me to understand what is actually happening in this PR and what are the code changes that were introduced. Then I will get kind of a detailed code like a review or a guide for the reviewer. So it might take it a couple of seconds. So I'm just going to go to an existing closed PR to see this now. So this is how it looks. And it basically provides a high-level estimate of the effort. It's showing areas of concerns, like I have a hard-coded API key here, I have some performance concerns. So this gives kind of the reviewer a high-level view of where they should focus on. And then it also provides like very specific and detailed code suggestions. So it will give you like a detailed structured table. I guess I can show it here, that shows specific code suggestions, and it categorizes them by different categories like security, performance, best practices. And then I can see for each suggestion what is the score for the suggestion, why it's important, and I can directly apply it here. And I can run a lot of these commands right here from the interface. So I can do like /ask, for example, and ask like, why is this PR important? And then a PR agent kind of listens to this. It will see that I asked this question, will identify the command, and then it will provide the answer like right here in the GitHub interface. And then we also recently introduced a Chrome extension that kind of really helps or really improves and adds to the user experience. So it helps me to kind of write the commands in advance, like with this additional kind of buttons. And then a really cool capability that we just added is the chat. So you can chat on the PR. You can even select specific lines and ask questions and do that right here from the PR like interface inside of your GitHub. So yeah, so with that, I'll just go to my last slide, and I can stay for a couple more minutes to answer if there are more questions. But basically, we believe that in the future, like we believe in a future where the developers are still in the driver's seat or in the cockpit, more correctly, in a very sophisticated cockpit, where they have the right tools to help them kind of manage and control the AI that is generating a lot of the raw code. So you need to be able to review code. You need to be able to incorporate the best practices of the enterprise. You need to be able to test. You need to be able to retrieve the right information and to document so you can understand what is going on and aligned with your spec. So all these things are core tenets of what we believe will be the future environment where developers will be able to generate high quality code leveraging AI. And that's basically it. So really appreciate
There's a bunch more
joining.
questions if you want to pick one or two to finish off. Sorry.
Sure, yeah. So okay, so IntelliJ, PyCharm, yeah, definitely supported. And then other AI powered tools like Test Trigger, testing. Yeah, so tools that are more focused, like your testing, for example, that are focused on more on the end-to-end testing. So it's very different. We are very much in the code. As you can see, we're like a coding assistant. We're in the code. We're in the code review. We may in the future also introduce like a more of like an end-to-end agent, but that's very different at the moment. I personally prefer ASCII doc format over Markdown. I don't see a reason why we shouldn't support that. I have to check with the team, but should be fine. And how do you work with diffs? What format do you ask for? Yeah. So we have a lot of know-how and techniques around line numbers and these kind of things. We're experimenting with a lot of different. This can be a whole other conversation. And how do you combine static analysis and RAG so they're not redundant? It's a great question. The way to do it is to use both methods, static code analysis and RAG, to bring in and collect relevant context, and then have a final step that kind of unifies them. So you don't provide duplicate context, for example, into the model. We do support C and C++. We support all the major programming languages across our tools. Yeah, so config file for CodeUmate. I guess we can take that as a separate, like just because we passed the time, but there is a config file for CodeUmate, and there's a very robust config file for PR agent as well. And yeah, code suggestions are based on both like best practices that are conventional, but also you can have your own best practices. And PR agent, for example, can read your best practices and then leverage them to suggest specific suggestions that are aligned with your best practices. So yeah, RStudio, Emacs, and Vim, not yet, but it's definitely those are areas that we're planning to, specifically Vim, like for example, for code completion. There are things that over the next, I would say, months, like to a year, like we will support how your testing component is efficient for software product lines testing. This is a very broad question. Like there is a lot of work that we do around collecting the relevant context, analyzing the code. Also in Cover Agent, we run the tests and we provide feedback to the LLM, and we leverage the coverage report in a smart way to include that in the feed to the LLM as well. So yeah, I think any plans to add security checks, privacy. So generally, like we are very, very security minded, right? Like if the question is around our privacy and security, we're SOC 2 Type 2 compliant. As I mentioned, we don't save your code. So that's on that. But then also we have specific, like I showed the example of the hard-coded API key, right? Like you will see suggestions that are related to security and privacy. We're not coming to replace like the current tools that are purely focused on security, but you will definitely see a lot of the security issues that are getting caught by a PR agent, and also inside of the IDE with our code review component. So yeah, with that, thank you very much. Hopefully this was beneficial, and feel free to reach out. We would love to continue the conversation, do kind of a deeper dive demo with your specific team. And yeah, thanks everyone.
We'll share the recording, so just be on the lookout for that. Yeah.
Awesome. Thanks, and have a good evening, morning, wherever you are. Bye-bye.